of you guys that are gone, I know a few people have been sick for quite a while. We're in section 10.1. We already wrote down the title. Pause this if you need to write any of this down. We talked about how a square root is. Guys, what's this sign again? Real fast, just everybody remember.
Radical.
That's what a square root is. We're going to talk about new functions called square root functions. Go ahead and pause if you need to write down any of this. And we're just starting on our example of graph. Seeing the graph of the parent function. If I was to fill in the table with -2, question. Is that going to be fun to plug in, yes or no? Robin's had it no. If I was to plug it in, why would it not be fun? What am I plugging it into? The square root, the radical. Yeah, no, you're good. Radical or square root, right? So in order to get this answer, I would have to take the square root from up above and put in a -2. Why is this bad? Exactly. If I do that in my calculator says what? Error. It doesn't work. Okay, so first of all, -2 doesn't even work. There's no point that goes along with it. Okay, so what if we were to go to a point that does work? How about -1?
Zero.
-5, -10, 0. Let's go there. So let's start at 0. Can I do square root of 0? Some people think no. Even like kids in calculus go, no, it doesn't exist. But hold on. Whoever has a calculator, I want you to literally do square root of 0. What times what is 0? 0 squared is 0. 0 times 0 is 0. Now 0 times a lot more is 0, but square roots ask who's squared. So you're double checking. Kaylee, yeah, it's good? Cool. So square root of 0 is 0. Let's plug that in our table. That's where we're going to start. Negatives aren't going to work. So we can start at 0. Now 1. How bad is it to square root 1? Not too bad, because isn't 1 squared 1? 1.
Yes.
Good. So we have square root of 1 is 1. Now, why might I not do 2 next?
Because then it's like
Decimal. Now, it doesn't mean we can't do it. You just have to get your calculator, and some of you are like, I don't have a calculator to do homework. Okay, you have your phone, but you guys know turn your phone sideways. There's a square root.
Yep.
But what might be a nicer number to plug into the square root that is still on this graph? 4, yeah. Let's do 4 instead of 2. So we get to be creative. If we're making the table, we get to make the table and choose what we want. So why is square root of 4 better? Because it is square root of 2. 2 squared is 4. Now, Diego already went ahead and said let's use 9 next because the square root of 9 is 3. Now, if we had room, if our graph was bigger, we could go where next? What do you think? 16. Because the square root of 16 would be 4. 2 times 8 is 16, but 4 times 4, that's the square root. 4 times 4 is 16. Now, I'm going to ignore this last point just because our graph isn't that big. See, it only goes up to 10 up above. Now, once we have a table, what do we do with those? Numbers. Okay. Now, remember when you graph points, you need to graph the x first and then the y, right? So in our first point, when we have 0, 0, where's that point at? What's that special point called 0, 0? The origin of our zero. Alright. Now, 1, 1 means go over to x equals 1, go up to y equals 1, and then find the intersection of y equals 1 and x equals 1, right? Okay, so I'm going to go ahead and just mark the point.
And then
Do the same thing with, so go over to 4 and take that line, 2, take that line, and that's where we're graphing that point, right? So we have 4, 2.
Whoa.
Oh, what's the last one?
9.
9 isn't written. You guys see we're going by 2's though, right?
Yeah.
Okay, just making sure. So we can go ahead and go to 9, and then we're going to see where that intersects with 3, and that's going to be our point, right? Now, kiddos, I know we don't have the decimals. I know we don't have all the in-betweens. Okay, come on back and focus. I know we don't know what's going on at 2 necessarily, or 5, or 6, or 7, or 8. But can you see where this seems to be going?
Definitely.
It's a curve. Good. It's not a straight line. It is going that way. It's not going the other way, which is a little different than other functions you've seen. It's going forever, but only, oops, I didn't even connect it very well. It's going forever, but only in one direction. Why only one direction? Negatives don't work. Now, if I was to get out my really snazzy graphing calculator, some of you have it, some of you don't. You don't really need it until Algebra 2. If you get out your nifty-difty graphing calculator, and if I was to graph the square root of x, And even if I was to change it up, maybe we'll put some pluses or minuses or multiplication in there and see if we can mess it up, if we can make it look differently. Lines go on forever both directions. Parabolas go on forever both directions. Not forever the other way. It doesn't go down. It goes up. Or maybe the other way as well. But if I was to open my graphing calculator, let's see if there's any way to make this square root. Let's put a 2 on the outside. Let's put a big old square root. Let's do something weird like, I don't know, x minus 7. My screen's kind of freaking out. All right, now let's go ahead and see what this looks like. Oh, hold on, my zoom's weird. That's not like a normal 10 by 10. Let's try this one.
Whoa, look at that.
Now, some things changed. There was a shift in the graph. There was even a stretch in the graph because of the numbers that I did. I'm going to actually move my window to make it, I wish we could pinch and zoom on graphing calculators. That would be nice. It's like a weird keyboard. Okay. If I was to do something like -2 is fine, and then I was to do x max to be something like 20. Okay, now what would change? What happened to my parabola? This one is at what point? 0, 0. This one's at 0, 1, 2, 3, 4, 5, 6, 7. Why did it go to 7? Oh, that's right. Well, no. Remember the horizontal shifts are backwards, what you think? The -7 moves it to the right, +7 moves it to the left. That was from Coach Trapp's lesson last semester. So it's probably been a while since you saw it. Vertical, if it's positive, like a plus, you go up. If it's a minus, you go down. But horizontal, it's backwards. But that's okay, don't worry. We're not testing on that right now. I changed it all around, but question. Pause. Shush. Does this graph go on forever? One direction. Does it go on forever both directions? No. It stops. Reason being, can anyone think of why there's not a point when x equals 6? Let me show you the equation again. Why does 6 not work? If you plug in 6, 6 minus 7 is what? Negative. And a square root of a negative? It's not going to work. It's not going to do that. So what's different about square roots? Their domains aren't negative infinity to infinity. Their domains are not all real numbers. For lines, that worked. For parabolas, that worked. For square root functions, no. The domain. Do you guys remember that domain is how far left to how far right? Domain x and range. Domain of the x's go this way. Left and right. How left does this graph go? X is 10 has a point, 9 has a point, 8 has a point, 7 has a point. We can make points for everybody except, what does it not go beyond? Yeah, it doesn't go beyond 0. So we have to say that x is bounded by 0. So we can say the domain is all x values above or equal to 0. All positive numbers including 0. Now wait, is there a snazzy short way? Rob, I'll put my pillow back and then sit up. That was completely unacceptable. Don't leave your seat again without raising your hand. All x values above or equal to 0. Guys, is there a cool math way of writing that? Oh yeah, we have to write that sentence every time. How do we write that? You can't say all real numbers. X, okay. Well, let me get a different marker just so we can show that it's different. X, now what? Above. Greater than. Remember the mouth is using the X? The alligator is using the X because it's a bigger meal. Greater than or equal to. We put the line underneath. And then 0. Okay, so domain. Not all real numbers then. Because if it was all real numbers, it would be negative numbers too. Now we could say something very like all whole numbers. There are different ways of classifying, and whole numbers are only the positives, but no, not even that, because decimals work also. All positive real numbers. Now, range. Do you guys remember what question? If domain answers how left on the x-axis and how right, So we say x can be 0 or anybody higher. Question, what does range ask?
For the y.
How tall, how high, or how low? So look at the y's, okay?
Wow.
How low did the y's go?
3.
0.
Yeah.
How high, now it's going to take a while to get there, but is it going to eventually keep going to all
Yeah.
y's? Yeah. So we have to say, okay, all y values above,
Zero.
so I don't know why I'm randomly making all cursive. Above, is it allowed to be at 0? Is it equal to y 0?
Yeah.
Okay, good. So above or equal to. Now how do we do that in notation again? Oh, y instead. Okay, so let me change it. Y greater than or equal to.
Zero.
Got it. To be honest, kiddos, this is pretty much today's entire lesson. But I'm going to show you a couple special things. Don't worry, not just most of these still have 15 minutes. That's basically all we're doing today. We're getting used to these square roots. But guys, look at the function. This was like one of the most basic types of functions. Can I show you the crazy one on my graphing calculator? Can we try to answer these 2 questions?
Yes.
Okay, I'm going to do that after addressing this question. Domain says look at the x's. My way of doing it is I think about this word with a little x at the end and this with a little y. So I call this domain x. It just sticks in my head. And this one is my little rangey because it with a y be rangy. Domain looks at x's, range looks at y's. For the x's, on the x-axis, every x will have a point down to 0. So it's allowed to be 0 or anything above. That's why we say greater than. And the y's, look at the y's. 0, nothing below. 0 or anything above is going to end up happening. Let's go to the crazy one in my graphing calculator. The one that I got all messed up. Transformed is the snazzy math way of saying it. Let me go ahead and look at the graph. I don't know why the buttons aren't pushing when I try to hit this, but just go ahead and do this. Okay, help me out. We're looking for domain, and we're looking for range. I'm going to go ahead and just do a little D for domain, which I've used. I don't know why it's up there. Which I've used before. And a little R for range. But remember, domain goes with what kind of values again? Say it louder, Justin. X values. And range goes with?
Y values.
So let's go ahead and think about, first of all, domain. Question. What is the lowest x value that's going to have a point?
0.
But there's no point at 0.
Or it's
7.
9.
7. We count up to 7, right? So how do we go ahead and say that? Rattling back is so x is going to be greater than, or is it allowed to hit at 7?
Yeah.
Yes, just like it hit at 0. Greater than or equal to 7. Okay? Because see how it's over to 7 now. Now, hold on, that's domain. Let's think about range for a second. Range is how low, how high. For this one, how low do the y's go?
0.
Greater than or equal to 0.
Yeah, it's still 0. And then it's going to go above 0. So the y's, 0 or above 0. Yeah. So the domain changed, but the range did not. Now I'm kind of running out of room, so let me put it up here. The range is going to be y is greater than or equal to 0. So some things might stay the same, but some things might change. And it all depends on the equation. What gets changed in the equation might affect the domain and range. The way that I changed it, this equation that I made, see if it actually works now. The minus 7 changed the domain, but everything else I did didn't change the range. So we're going to see today what changes happen when the equations change as well. Let me go ahead and get the notes up, Dylan, and come right back to your question. All right. I just want you guys to write down. And notes are kind of short today. There's not a lot of words. Go ahead, Dylan.
Like how would you know that the range is like not equal to 0?
We're getting used to the square root function, and I'm trying to show the square root function. He goes forever one way.
Okay, yeah.
But then, when he comes down to a point, he is going to stop somewhere. So the goal is for us to figure out where that stop is, and then figure out what is that y value where it stops.
Okay.
Does that make sense? So on the one in my graphing calculator, oh, that's good. I didn't know that. Okay. I don't know what I hit. In the graphing, yeah, no. In the graph, I saw this one. It went down, it hit the x-axis, and it stopped. That's why I'm saying
Okay.
0.
So is it always gonna be 0?
Let me show you the what if I was to do something like, it's actually a trick, I can hit second. What if I do plus 2?
Okay, so
See what I mean? So now we have to figure out when does it stop, and guess where it stops? At 2.
2. Okay, so okay.
Yeah. So if we can remember what those numbers do, that might help, but if we can get a graph, that'll help us.
Okay.
Y would have been greater than or equal to 2. Y would have been greater than or equal to 2. Let's make sure all the numbers, let's just make sure I'm just right. You have 45. I get one more chocolate. They made it so lunchtimes were the same. That's so that you had to like Alright. Now kiddos, go ahead and make sure you get this written down. If you're behind in your notes, your goal tonight is to get caught up. Please, please, please. Because if you don't take notes, it can be hard. Or if you're not watching right now, hopefully you go in the videos tonight and you write it down later. I don't mind that, as long as you're doing it. I want it.
Sometimes I get doctor.
Very. Huh?
No, it's true. Because if he's gonna watch it later on tonight, and he's like talking to himself later on, it's gonna be time sensitive anything. Alright, you'd be like, keep it up, Jay. Keep doing what you're doing. Keep taking those notes. Jazz, you too. Alright, kiddos, here's the dealio. I need you guys to help me fill in the blanks, because I didn't fill in everything. As you notice, there's like spaces randomly, right? Okay. So domain. I want you guys to go ahead and, hold on, pause. Hold on, pause. You guys see a radical, right?
Yeah.
Now there's the parent function that we've already talked about, radical x, and we already looked at this graph on the page before. He goes on forever one direction, but not the other direction. Okay, whatever's making noise, please. I don't know what it is, just stop. And I already said I'll spin this away and see what I cause. I'm done. So square root of x, it goes forever in one direction, but not the other direction. However, guys, under domain, do you see a radical with nobody underneath?
Yeah.
What's going on there?
He's thinking.
I'm trying to say something's underneath, but I don't know what. I'm going to put a little box there to say something's underneath. Maybe it's an x minus 7.
Yeah.
Maybe it's a 3x. I want you to.
Maybe it's an X.
Maybe it's a 3x.
Maybe it's just X.
But whatever is underneath, hold on, I want you guys to remind yourselves that whatever's underneath is called the radicand.
Oh, can.
And then this outside, what we've already said, is called the radical. Now both of these pieces are important for a square root. The radicand, what's underneath, and the radical, what's over and above. If I was to be super specific, like the book maybe, I would say something like every square root function has a radical and something with an x underneath. Okay, now I'm not going to write x because you guys might get confused by that. So instead I'm going to go ahead and put a box, and somehow there needs to be an x inside. There's some sort of x. It might be an x alone, it might be an x plus 2, it might be a 3x minus 1, it might just be a 5x. But an x somehow is in the radicand. I'm going to go ahead and erase because this box gets a little confusing. And I'm not trying to be all technical and give you definitions. But here's what I need you to see. The radicand, which is, remember, whoever is in the blue box, whoever is underneath the radical. For domain, we always take that underneath, that radicand, and say, wait a minute, you guys, wait, you figured this out. Who's not allowed, what type of numbers are not allowed to go under a square root? Negative. So if it's not allowed to be negative, I have to fill in and say, okay, what do I need to think about every time I think about domain when the x is somehow underneath the radical? I need to take whoever's underneath and set them greater than or equal to 0. Why? Negatives aren't allowed. Negatives under the radical. Negatives under the radical do not exist. Now, I don't need you guys to memorize that. Some of you already have like just a natural understanding because we've done some radicals, we've done some square roots. Negatives under the radical, under a square root. We're not dealing with cube roots or anything like that. Negatives do not exist. They're imaginary. You can't do a number times itself and have it be negative. A positive times a positive is a positive. A negative times a negative is a positive. Whatever sign you have, it needs to be the same for a square, and it's always going to be a positive number. So, I need you guys, if you're highlighting types of people, to go ahead and highlight domain, and highlight radicand greater than or equal to 0. And this is something that I keep on teaching kids at every level. Algebra 2 kids, review this. Pre-calculus kids, review this. Calculus kids, need to review this. For square root functions, domain, whatever is underneath the radical, must be greater than or equal to 0. Now, how does that help? Without a graph, if we were to have something like this example, 3 square root of x minus 5, can anyone identify for me, now you can show a box, or you can actually write the word radicand. What is the radicand of this square root function? X minus 5. If it helps your brain, you can literally say it's everybody underneath. Draw a box. Radicand is x minus 5. So how are we going to describe the domain? We use what? Yeah, what's right above. Take the radicand, take the box, x minus 5, and set him what? Greater than or equal to 0. It says easy as that. Take the radicand.
It's always greater than 0?
Set it greater than or equal to 0. Now we're not done, because we got to get x alone. But we have it set up and ready to go. Some of you have already started to solve this. We've set it up. Radicand greater than or equal to 0. Then we have to go ahead and use some algebra to say we need to get x alone. So we add 5 to both sides. X greater than or equal to 0. Kiddos, this is the beginning section of homework. Take a square root function, find the radicand, set it greater than or equal to 0, solve for x. Some are harder, some are easier. Take the radicand, set it greater than or equal to 0, solve for x.
Why wouldn't you add 5 to the other side? Why wouldn't it be x?
Oh, because I'm silly and I was talking and not paying attention. You guys ever talk and not pay attention?
I do that all the time.
Oh.
Okay. 0 plus 5 plus 5.
You got time.
Okay, hold on, come on back. This is part 1 of homework. There's only one more part, really. Okay? Part 1 is domain. Part 2 is range. We already talked about range. Domain says how left can it go, how right can it go. It's going to go forever in one direction. So we're going to use that greater than or equal to say it stops somewhere. But if we see the equation, we can say radicand greater than 0 solve for x. If we see a graph, we'll look at it, just like we did in the first example. Now for range. Remember, range is answering the question for y's, right? Range is looking at the y values. And we're going to call it range, but if you want to think with me, rangey, I've said it a few times. Rangey, it's just a way of remembering. Rangey, oh yeah, that ends in a y. Now, focus. Looking at the y values. Usually the easiest way to look at the y values is get a graph. And if you guys want to think about it and want to review, I've mentioned it earlier this year. How low does it go? How low, and I'm going to put a little slash, how high. How low with the y values and how high with the y values. Okay, the nice thing is you've already done one of these types of examples of making a graph. We start with making a table. X, and in this case, g of x. Now, if you look, can you guys see your square root in this function? Where's the square root? Just over the x.
Oh.
The 4 doesn't have them. The minus 4 is on the outside. So question, do I want to start my table with a -2? Is that going to go well under a square root? Oh, no. No. So where do you think I'm going to start my table?
Now.
So start at 0.
Settle.
Now, focus.
Spanish.
Guys, we have to wait an extra minute now. Listen. If we plug in square root of 0 minus 4, that's 0 minus 4, which is -4. Okay? Now, I'm not going to make you guys do all the rest of the table. I'm actually going to help you by saying 1 is a good number to plug in, 4 is a good number to plug in, 9 is a good number to plug in, and we'll stop because it gets really big at that point.
So you should only use those ones?
And if you plug in 1, square root of 1 minus 4, 1 minus 4 is -3, right?
Why is it -4?
Because the function tells me so.
Oh.
One more minute. If I plug in at this one, square root of 4, guys, I said just 1 minute, don't make me add, I don't want to. 2 minus 4 is -2, and if we did one more, square root of 9 minus 4, 3 minus 4 is -1. Now, if we get a graph, questions will have to wait because some people want lunch. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have all the way to 9. So I have 9, I have 4, and I have 1, and 0. I can graph -1, 2, 3, 4. Give me 1 second. Okay, we're going to graph our 0, -4, our 1, -3, our 4, -2, and our 9, -1. Do you guys see the square root function?
Yes.
Help me out. If we're thinking about range, how low does it go? What's the lowest y value that's possible? So how are we going to write the answer if -4 is the lowest y can go? Greater than 4.
Or equal to 4.
Kiddos, I'm going to have you guys take a picture of the homework. You have to show it to me before you leave. But pause. Have we talked about domain? Have we talked about graphing and range?
Yes.
Okay. You ready?
Yes.
It's easy. It's easy to remember, easy to write down. Do the best you can. Don't get discouraged. Do the best you can. I see it. I see it. I see it. I see it. Thanks, Gary. I see it. Even good job. I see it.
Swell, did you see that?